Okay.
Great, can we start whenever?
Yep, go ahead.
Okay, I guess we'll begin now. So hello, we are Jules in Lockdown, and we've done some analytics with electric vehicles for Chargepoint. Next slide. So pretty intuitively, an absence of data analytics can lead to a lack of infrastructure and weak grid planning, both decentivizing a transition to electric vehicles for various reasons. So we can capture already existing electric vehicles and charging stations, and we've done some optimization in the last 36 hours.
With one of the graphs that we were looking at for the Chargepoint data, we graphed residential and work energy consumption over about a week. Next slide. Looking at the data, we found some very unique trends where you could see that there are dips between days, as well as it's not completely like complementary graphs, where you do have minimum points near the 6 a.m. times, as well as you can see where the peaks are for work versus residential. Next slide. We also looked at different data sets from Caltech, where they had about 108 different EV stations, and they looked at one area in the Bay Area, and then one or two locations in Pasadena. And then you can also see that the amount of time for actually charging the battery is significantly less than the actual connect minus disconnect time, which is the amount of time the car is physically connected to the charging station. And then on the right, you can see the California ISO data, where you can see the duck curve, as well as amount of curtailment, so amount of energy that is not actually being used for any kind of purpose. Next slide.
So ultimately, this brings us to our solution, which is more effective vehicle-to-grid modeling. So with the previous data that we presented, it's evident that there are many mismatches in supply and demand, as well as dips and peaks as to when EVs are charging. So with our solution for vehicle-to-grid modeling, we hope to inform utilities, grid operators, and policymakers, as well as to build stronger incentive programs for EV users when deciding when they're charging. So ultimately, with V2Grid, V2G bidirectional charging, we would optimize electric vehicles as well as charging station batteries in order to increase grid flexibility and utilize our data to including the remaining capacity on the grid as well as demands, and also model the value of storage that is provided from vehicles. And for instance, with the projected growth of EVs in 2030, by 2030 in California, we would be able to avoid approximately $26 billion in stationary storage capacity when optimizing EV storage.
Yeah, so like Lisa was explaining, our solution is a dashboard with data analytics, providing data to and EVSE operators to increase grid flexibility. So this dashboard will contain two models. The first one being an individual EV model. It'll contain two layers, one layer with nodes of electric vehicle charging stations, and a deeper layer with individual electric vehicles. So an example of an input to this model will be data from individual electric vehicles. For example, how much battery is like a Tesla Model 3 on a given day, 30%, something like that. And how much more the EV will drive that day. Historically, or using some type of predictive model, you can figure that value out. And next slide. So using some type of predictive modeling with this, with Model 1 or pattern recognition, maybe a neural network, we can determine the total supply of V2G from individual EVs and EVSEs connected to the grid. This data then is brought into another model where the output is to, next slide, is to EVSE operators like Chargepoint, helping them decide whether to charge an EV or use the EV as an asset in a grid, V2G. So this decision-making process will help reduce issues with the duck curve, for example, and increase flexibility of grid capacity.
Great. So on this slide, we just have a GIF here of the dashboard with the preliminary data that we've created for you guys to play around with. And next slide, there's a QR code here. And I assume you guys will get the slides afterwards, so you can scan this and go straight to the dashboard.
And moving forward, we hope to gather more data, including the capacity of EVs throughout the day, as well as expected capacity needed for individual drivers for predictive analytics, and how to incentivize level 1 and 2 charging over DC fast charging in order to mitigate spikes on the grid. And we hope to better understand the value and cost of storage at different times of day. So thank you so much for listening to our presentation, and we welcome any questions.
So how would you imagine getting access to the data and incentivizing people to give you that access?
Yeah, that's a great question. So one of the components of incentivizing different types of charging for B2G participants would be kind of optimizing time of use rates and giving economic benefits for users to participate. And we would need that data in order for those calculations for how much storage and value they've provided to the grid.
So would you see it being the individual drivers that you'd be working with, or would you think about working with any other players in the ecosystem?
Yeah, I think in our discussions, we did talk about working with multiple stakeholders in this process. So while it's great to incentivize individual EVs, I think along this value chain, we would definitely have to target, potentially EV/SE operators. For instance, if vehicles are primarily charging at their workplace, then working with the charging operator at the workplace to gather that data with the permission of those who utilize those chargers.
Yeah, I think to quickly add on to that, the Caltech data is in collaboration with PowerFlex, and so they work a lot. They're a company that works a lot with EVs as well, and so they, I think they anonymize the data so that it could be used for research. But the reason that they collaborate with Caltech is because they have a lot of research initiatives to try to get their campus to a net zero carbon emission campus, and so those kind of opportunities I think are useful to keep in mind, especially since that could be useful to try to understand the landscape, but also how can we better inform utilities and policymakers who are already supporting these research initiatives.
Thanks. Great use of the QR code, by the way. I pulled it up.
Yeah, I pulled it up quickly too. Have you looked at any other like grant-based projects on topics like this? I think the CEC and other groups actually fund a lot of these kind of projects. It could be an area of a way to fund something like this. But.
Oh, that's really cool. Thanks so much for sharing. We'll definitely look into that.
Yeah. I don't know if I have any questions. Andrew, did you have any questions on the data aspects?
Not on the data aspect, but I was wondering if you see a path for this data to be like a viable business, or how would you commercialize it and kind of take it from just being a data to being like part of the business model for organizations?
Yes, if you go to the previous slide with the model, sorry, I think it's there we go. So you can see there's multiple aspects here that we can, if you do make like this data analytics part into a business, commercialize it, there's multiple parts where you can economically benefit, right? You need this third party, which would be us in this case, that would process the analytics, create this, some type of neural model, and sell that data to, EVSE operators like Chargepoint or other operators, sell that data to different stakeholders like grid operators, and to even sell that data to maybe individual EV consumers.
And you would sell it as a data package, or you would sell, perhaps access to APIs where you can do calculations in real time. Like what kind of interaction model did you see here?
So in the discussions we had, I think the most viable one would probably be like an SaaS, like a software where you have like a subscription to some type of platform like an API. I think that seems the most feasible, and when in terms of business model, that does seem the most economically viable as well.
Thank you.
All right, I think that wraps it up. Thanks, team Jules in Lockdown.
Thank you so much.
Thanks so much.
Thank
It was
you.
great to work on the challenge.
Yeah, thanks a bunch.
Thank you.
This is great.
So now we have an official break.
Yeah, we had great conversations with that team. They're I can't believe they got a working dashboard running in 48 hours.